Okay, let's take a look at a handful of these practice problems, and then you'll have a lot of practice problems in the homework. Definite integral of 2 sine u plus 3 cosine u going from 0 to 4 pi. So the fundamental theorem says let's do the antiderivative, plug in the upper limit, subtract what we get when we plug in the lower limit. So the antiderivative of sine is negative cosine. So this is actually going to be negative 2 cosine u plus the antiderivative of cosine is positive sine. So plus 3 sine u. And now let's plug in my upper limit and then subtract what I get when I plug in my lower limit. So this leads me to negative 2 cosine 4 pi plus 3 sine of 4 pi, and then we will subtract negative 2 cosine of 0 plus 3 sine of 0. So let's see if we can evaluate. The cosine of 4 pi, that's the same as the cosine of 2 pi or the cosine of 0. And so that's going to be equal to, that's equal to 1. So this ends up being negative 2 plus 3 times the sine of 4 pi. Now the sine of 4 pi is 0. And so 3 times 0 is 0. And then we end up with, well, 0 is coterminal with 4 pi, isn't it? And so it's probably not a surprise here that this ends up being the exact same inside these parentheses. And so you end up with negative 2 minus negative 2, or a net effect of 0. So your answer to number 1 would be 0. Number 2, doing the definite integral of 3 over t to the 5th going from 1 to 4. So the first thing that I would do is I would rewrite this as 3t to the negative 5. Then I'm going to pull that constant out, and so I just don't have to worry about it at all. So this will be 3 times, so the 3 is kind of out in front. Now I'm doing the antiderivative of t to the negative 5th. So add 1 to that exponent, and then divide by that exponent. And we have to evaluate this from 4 down to 1. So this is equal to negative 3 over 4t to the 4th, as t is going from 4 to 1, or negative 3 over 4 times 4 to the 4th minus negative 3 over 4 times 1 to the 4th, or that'd just be negative 3/4. And so this is kind of an obnoxious looking answer. It looks like here we have negative 3 all over 4 to the 4th times another 4 all over 4 to the 5th, and then plus a positive 3/4. So I'm just going to put this, you could probably put this into the calculator or something. Let's go over here and do that, see what we get. So we have negative 3 divided by 4 to the 5th, and then we are going to add that to 3/4, and that gives me an answer of 0.747. And so if I convert that to a fraction, I get 765 over 1024. Not that you necessarily have to convert to a fraction, but sometimes it's cleaner to write it like this than it is that long decimal. Okay, question 3. Let's find the average value of the function on the interval. And in this case, if you're finding an average value, immediately go to the average value of the function formula. So that's going to be 1 over b minus a times the definite integral of my function from a to b. And so this is equal to, in this case, 1 over, you'll have 5 minus negative 5, so that'll be 1/10 times the definite integral of 18 minus 9x squared going from negative 5 to 5. So this is 1/10. I'm going to do the antiderivative of this now, so that'll be 18x minus 9 times x cubed over 3. Have to plug in 5 for my upper limit, negative 5 for my lower. So I get 1/10 times, this will be 18 times 5 minus, now I could simplify that. The 9 over 3 just becomes 3. So minus 3 times 5 cubed. And then subtract 18 times a negative 5 minus 3 times a negative 5 cubed. And so let's see if I can clean this up and get a nice looking answer. So we end up with 18 times 5 minus 3 times 5 cubed all over 18 times negative 5. Okay, and I think let's just plug this into the calculator and see what it does. So let's go 18 times 5 minus 3 times 5 to the third gives me an answer of negative 285. So I end up with 1/10 times, it'll be negative 285 minus this quantity right here. And if we do that, if we say 18 times a negative 5 minus 3 times a negative 5 raised to the third, that is just 285. So be careful here. That's not negative 285 minus negative 285. It's negative 285 minus 285. So we end up with negative 570 divided by 10, which when you simplify that, it leads you to negative 57. So the average value of that function is negative 57. Don't forget, with the average value of the function, you're not just doing the definite integral, you've got the 1 over b minus a in front. A lot of times I see students miss that. Okay, example 4. This looks like it would be one of those second fundamental theorem of calculus problems, but the reality of it is we have not generalized a formula like this. Do you remember we did generalize? We said if we had the derivative of an integral going from a constant to x, we said that that was going to be equal to just f of x. And we also said if we did the derivative of a function, of the definite integral of a function going from a constant to x squared, that would be, or not necessarily x squared, but that was the example we saw. This could actually be any function of x right here. I think we called it g of x. That this would actually be f of g of x times g prime of x. But we don't have that here. So how do you solve this question if you don't have one of these shortcuts? And the reason we don't have that here is x, this lower limit of integration, is not a constant. It's not like a. So we actually need to evaluate that definite integral and then do our derivative. And so this is one of those variations that I was saying we might run into. So this is the first thing I'm going to do. I'm going to just do the definite integral of 10u plus 3 from x plus 1 to x, and it's going to lead me to the following. It's going to be 10 times u squared over 2 plus 3u. I'm going to plug in x plus 1, subtract what I get when I plug in x. So this becomes, you can see that that's 5u squared plus 3u. So simplified, it's going to be 5 times x plus 1 squared plus 3 times x plus 1 minus 5x squared plus 3x. But remember, this is just the definite integral, and eventually what do we need to do? We need to do the derivative of all of that. So you might as well just do the derivative of it right now. You know, we can say, or we could simplify it. It really doesn't matter. But if I did the derivative of 5 times x plus 1 squared plus 3 times x plus 1, and then what I might do is just distribute that negative through, so we have minus 5x squared minus 3x. We can do the derivative of each piece, and then we'll have our answer. So what's the derivative of 5 times x plus 1 squared? Well, this is chain rule. This is where you would take the outer power, you'd multiply, so you'd end up with 10 times x plus 1 to the first, and then multiply by the derivative of the inside, but the derivative of the inside is 1. Here, this is, you could distribute the 3 and see it's 3x plus 3, or when you do the derivative of this, it's just going to end up being 3. The derivative here will be minus 10x. The derivative here will be minus 3. So wow, look what we end up with. 10x plus 10 plus 3 minus 10x minus 3. So the 10x cancels with the minus 10x, the 3 cancels with the minus 3, and we end up getting a final answer in this problem of 10. This falls into that classification of weird problems involving differentiation of definite integrals. And again, you're not going to see a lot of these. I believe that you might see one either like this or like one of these other ones that we've talked about already. You're going to see at least one of those in the homework in WebAssign. So check that out now and post your questions to Facebook. Let me know if you have any questions through email, if you don't want to post on Facebook, and we will get through this. And now that we have this section complete, we've only got a couple sections left in all reality. So you guys are almost there. Hang in there.